Welcome to another video from Lockdown Electronics with me, Bill. This time we're going to take a look at an eBay purchase that I recently made, which is the Simpson Model 465 Series 3 auto ranging digital multimeter. Now, Simpson are North American manufacturer of instruments, good quality instruments, and when I saw this on eBay, read the description and thought to myself, I'll maybe bid a little bit on that and see how we get on. And I'm very pleased to say here's a screen grab of the final screen that I won it for just over 13 UK pounds, so really not very much money at all. And at the time I'm beginning to think that perhaps I'd possibly bought just an expensive case. But let me just read to you the description the seller had put on, and he's put vintage Simpson auto ranging digital multimeter model 465 series 3. They love the word vintage. They must think it just attracts more money, and maybe it does, I don't know. This was recently got from a clearance. I know nothing about it. Cosmetically in good clean condition for its age. Absolutely, it's in actually lovely condition for its age, complete with a Simpson electric tag still on it. I guess this is probably late 70s. I've not been able to find any information on the internet about it. Well, not very much. Certainly can't find a handbook or a schematic or anything, so if anybody does know where I could get one, I'd be possibly put that in the comments. That'd be absolutely great. So yeah, good cosmetic condition. Now here's the bit that makes you cringe. I turned it on and some red appeared on the screen, then it vanished. Now nothing happens, so selling it for spares or repair. Okay, the old adage, be careful what you plug in. So if you step through the pictures, so have a look at this picture, which is the rear of the instrument, and it says very carefully, power 120 volts AC, 50 to 400 hertz, 10 volt amps. So it's 120 volts, and as this is the UK, he's undoubtedly put 240 on it, and you can see it's a standard Euro connector there, so it's easy to plug your kettle lead in or whatever you've got handy. Now, in his defence, it does also say here, line fuse, quarter amp, 250 volts, 3 amps, normal blow. So actually that's talking about the fuse, and it does clearly above it say that it's 120 volts. But hey, if I've been tatting with electronics since I was a kid, so to me that's extremely obvious, but maybe it isn't to others. So I knew when I bought this that I was taking a chance, and I didn't bid very enthusiastically, and actually I think I bid 15 quid, and I really didn't expect to win it, so I was quite surprised when I did. So I don't have a schematic. This is the bit of kit. It arrived yesterday, so I've unpacked it. It was nicely packed as well, so time to take the covers off and see what's what. So here's the bottom of the instrument, and there are 4 rubber feet with old-fashioned slot head screws to remove, so I'll get these screws out and then we'll see what horrors unfold when I take the lid off. Okay, that's the 4 screws removed, so I'm going to hopefully just find that this lifts off, which it does. Okay, oh, that's not quite what I was expecting. I'll just put these somewhere out of the way for a minute. So that looks like some kind of 4 D-size rechargeable nickel cadmium batteries. Oh, okay, and those must be the tubes to contain them. Doesn't look like it's ever had batteries in by the condition of the connectors. Okay, that's a bit of a pleasant surprise, that if there's no damage to the internal circuitry, maybe I can sort out the power supply and supply it through the battery supply, but we'll just have to have a look. Okay, let's see what we've got. Right, I've repositioned the camera so we can at least have a look at the general arrangement. Obviously without a circuit diagram or a handbook, I'm going to have to just use experience and a bit of intuition. So we've obviously got mains transformer there. I say obviously because it's right by a fuse that's labelled with mains voltages, so I'm guessing that's the mains fuse. There's a fuse here and a fuse here. I guess those are fuses to do with the measurement part of the instrument, and I'm guessing that all this over here is to do with measurement, and this is certainly power supply. There's a fairly chunky 2200 microfarad electrolytic there, so we'll have to check that. This is at least 40 years old, so we need to see what condition that's in. That may need replacing. That looks relatively straightforward to replace anyway. They're taking no chances. It's been you can see there, it's been held in with a cable tie, so perhaps they were worried about it being vibrating about. So just based on what the seller said, he plugged it in, and there was a bit of a flash on the display, and now nothing happens. Well, it does say very clearly it's set up for 220 volts, so that means he's put mains voltage across the primary, and that's pretty much double the voltage that it was designed to have, I guess, since we're about 240 here in the UK. So fingers crossed that that fuse went before the primary of the transformer went. So I'm going to just prise that fuse out. I've been very eager to do this because I'm hoping this fuse has gone. It's not easy to see at all, but to me, holding that up to the light, yep, that fuse has blown, so that's a good start. I'm just going to pop the meter onto continuity, and it would help if the probe was in the right hole. So that's continuity, so we should have no continuity here. Okay, that's good news. Fuse is open circuit, so I'll leave that to one side. It's a standard 32mm fuse, or for those of you listening in America, that's 1.25 inches. I suppose I should say it's 1.25 inches as this was made in the USA. So I'm going to go back to go to ohms now, and there's the primary, and over this side, now well you can see it, we've got 3 connections, so I'm guessing that's going to be a center and 2 supply rails. There's 2 diodes there, so I'm guessing they're both oriented in the same direction, so I'm going to guess that that's full wave rectification with the center tap, but we can check that if the transformer lives. So if that fuse has done its job and protected the transformer, we should be able to get resistance across those 2 terminals. So I'm going to put the probes on there as best I can, and it's telling me 116 ohms. That's very good news. Try and get a better connection. It's about 110, about 110 ohms across there. Now there's a couple of other connections on here, so while I've got them, I'm going to just leave my first probe on there. So this first tap is 109 ohms. What's that one? That's 316 ohms, and that one is about 360 ohms. So I'm going to hazard a guess that that's 120, 220 and 240 at a guess. I'll perhaps do a bit of maths, but I suspect that we might be able to make this work off European mains voltage. Yeah, so that appears to be the taps. But first thing I'm going to do is I'm going to put a fuse in there, and I've got a 120 volt step down transformer to use with some other American equipment that I've got. So I'm going to attach the instrument to that and see if anything happens. So I'm going to set that up, and then we'll carry on. Okay, new camera angle so we can hopefully see everything that's going on. This is the step down transformer. It says there that it's a foreign electricity converter, so we don't know how it's going to work on English electricity. Hopefully it's going to be okay. But just popping the leads into the plug there for the output, we're getting, and you can probably just about make that out, the top left there, we're getting about 118 volts AC, So that's good. So I'm going to carefully plug that in, obviously bearing in mind here there are connections which will be live when it's plugged in. So if you're thinking of doing something like this, usual disclaimer applies: don't do it if you're not sure, because you could get an electric shock, and you do that at your own risk. So I'm going to plug that in, and I'm just going to check I've got 118 volts here in the primary of the transformer, and yes, I have. Just going to check what I've got on the secondary. So I'm going to put one lead, I'm going to put the negative lead on the center tap. Going to try one lead. Okay, I'm getting, now that's interesting. So I haven't switched it on yet, and that's energized. So maybe there's a circuit involved there that charges the batteries when the instrument itself is switched off. So from the center tap to the outer tap, I'm getting 8.5 volts, and I'm going to try the opposite side. Apologies, I'm in front of the display there, you can't see what I'm doing anyway from that side, I guess. Yeah, so I suspect that's a 909 secondary transformer. So okay, let's be very brave then and just spin that round, and I'll just, hopefully you can see that. I'm going to press the on switch, see what happens. Aha! And there we go, we've got the display lighting up. So she lives. So clearly there's a couple of things whizzing through my mind right now. You know, remember the seller said that he switched it on, there was a bit of a view on the display, and then there was nothing. And I guess I was thinking the moment you press the on switch, everything gets energized, and potentially you get the wrong voltage on the secondary as well momentarily, which could do some damage to the power supply circuitry, possibly even further downstream. But what I didn't realize till just now is that when that switches off, the transformer is still energized. So that fuse would have blown within, you know, milliseconds of it being plugged into the wrong voltage. So there's no way by the time he pressed that button, unless it was already pressed when he pushed the mains lead in, that that would still have been energized. So maybe there was a little bit of residual power in some of the capacitors, maybe. So I don't know. But clearly we've got a bit of a result there. So I'm just going to check what's happening. I'm going to go into DC volts here. I'm just going to check what's happening across this supply capacitor here, and that's at about 11 volts. So yeah, that's okay. It's a 16 volt capacitor, so it's well inside its safety range. I'm going to disconnect the power for a moment there and just set up to do some more testing. Okay, yet another camera angle. I wanted this time to get the display of the LCR meter in, so I'm just going to check this 2200 microfarad smoothing capacitor, and sometimes the LCR meter will give you an answer even when it's in circuit. So I've discharged the positive side to chassis, so I know there's no charge in the capacitor. So I'm going to pop the leads on. I've got it in electrolytic capacitor mode. 2200 microfarads it says, and it's telling me 2.46 millifarads, so 2400 microfarads. We can change the secondary display through to ESR, and it's saying 0.04 ohms. Now that's at 1 kilohertz. Now what I have got the ability to do on here is to change the frequency, so I'm going to step right through to 100 hertz and see what I get at 100 hertz. That's because I suspect that's the frequency this capacitor will be dealing with. It'll be dealing with 100 pulses per second coming off the two diodes. So we've got 2.41 millifarads, 2400 microfarads, and an ESR of 0.06 ohms. So I'm going to get my little ESR chart out and have a look if that's reasonable or not. If it is, I'll probably leave it. If it isn't, I'll probably change that capacitor and then I'm going to have a look at what's going to happen with the transformer. So I'll just have a look at my chart and see if the ESR looks reasonable. Okay, so that was the capacitor I was checking, and according to my little ESR graph, the capacitor of that voltage probably gets away with about 0.1 ohms, and we're getting 0.06, so actually that appears to be saying it's alright, and it does look in reasonable condition, so I'm going to leave that for now. So next thing to do is decide what's happening here with the transformer. We've got some extra taps, so I think what I'm going to do, based on the measurements I got with resistance there, is I'm going to move that lead onto the end tap there, put 240 volts into it, and see if we're still getting the 909 either side there. And I'm going to do that before I switch the instrument on. I'm pretty confident I am going to get that, because the ratio of the resistance to the voltage just seemed to work out okay. So I'm going to get the soldering iron and move that across, and then we'll do some more testing. Okay, that's the lead moved over onto the fourth tap, and I'm pretty confident that's going to be the 240. We've got one end of the winding there, and I think we've got 120, 220, 240. I've put a few little marks on there just to remind me. So I'm now going to I've now got 240 volts, actually, just to see what we do have actually going on here in the UK. That's currently telling me 237 volts we've got going on there from the UK main. So I'm going to plug that in. There was no immediate bang. Remember, the main switch doesn't work, so the transformer energizes immediately. I'm just going to check I've actually got 240 across that, and yep, I have indeed got 240 across that. So now I'm going to just whiz it round here to the secondaries, and I'm going to put that on the center tap. I don't know how well you can see that, and I'm going to check. I should run about 8.5 volts here if it's working okay. 8.58, that'll do for me. Let's just try the other tap. 8.6, yeah, okay. So the AC voltage coming off the secondary when I'm on that tap is pretty similar to what it was on the 120 volt. So we'll just switch on and see what happens. Yep, seems to be working fine off mains voltage. So I'm going to just unplug that, because I'm acutely aware that there is a lot of mains voltage here that's currently sort of exposed while I'm talking about it. So to recap then, it looks like the fuse did its job. It blew before the primary windings on the mains transformer blew. Well done, Simpson Electric Company, for putting a transformer in that's possible to change the voltage on. So that now should be okay on 240. So what I'm now going to do is I'm just going to check that these two fuses are okay and for continuity, and then I'm going to reassemble it, and we can have a look what kind of readings, if any, it's capable of giving, because all we've done at the moment is proved we've got power again. So I'll put it back together, and then we'll see what we get. Okay, machine's back in its case. I've got it powered up and just warming up, as I've got this instrument powered up as well. So I'm going to change that to ohms. I've got the Simpson set to ohms, and I've got it to low. There's two versions of this, low power and high power. I'm not quite sure, so I've kept it on low. And we've got a meg ohm and a k ohm light there. Currently it's obviously open circuit. Some Simpson meters have a different type of connector to the conventional banana plug, and that's what this has got. So I've got a couple of adapters on order. There's a very good video by Alan Walk, W2AEW, who talks about some of the Simpson portable meters, and he actually shows you a couple of solutions for the being able to adapt these connectors. I could change the connectors, but I'd rather not do that. I'd rather leave it as it is. So adapters on order, expect them later this week. So I've just got a couple of some resistors here. So I'm just going to put it first of all onto the multimeter, the conventional multimeter, and we're getting, this is telling me, the east tester is telling me that's 3.26k, which is what I would expect. It's a 3k3, so 3.26 is what the east tester makes of it. I've not done anything here yet, so I've got no idea what this is going to make of it, but so it's all up for grabs, and currently it's not doing anything. I suspect that might be the poor connect. There we go. Yeah, 3.32. all right, well, I'm pleased with that. The K-ohm LED is a light, so that's saying 3.2k. right, well, that'll do for me. Nice one. So let's just try this here. We've got a much higher value here, so first of all put this on the east tester, see what the east tester makes of this one. Whoops, if I can just get the bulldog clips open. I think that might have it slipped off the end of there. I'm not doing well here today, am I? There we go. So that's 2.23 megohms is what the east tester is making of it, and this is 2M2, so that's 2.23 is what the east tester says. Let's see what the Simpson makes of that. .267, and it's lit. The megohms is lit, so it clearly does work all right. There's lots of trimmers inside there, and without a manual I've no idea what they do. They aren't labelled as such, so I guess it's possible to calibrate this, and that's something I probably need to look at doing at some point. However, in terms of what I do as a hobbyist, actually this is already accurate enough. So next thing I do is to check the voltage and the current ranges, so I'll get set up for that. Okay, it's going to be fairly easy to check voltages. So I've got both meters connected to my DC power supply, and it's currently set to its lowest level. The DC power supply doesn't think it's giving out any volts, but the Simpson thinks it's giving out 0.05 volts and 0.051, and interestingly so does the east tester, so that's actually bang on at that point. So what I'm now going to do, if I can keep my hand out of the picture for you, is just increase the voltage up to maybe about 1 volt, something like that. Went a bit far there. That's about 1.15. Oh, okay, well, that's pretty accurate. Let's go up to about 5 volts, see if she works okay there. So that's about 5 volts, 4.95, 4.96, blimey, can't argue with that. Let's go up to 9 volts, see what's happening there. That's 9.02, that's saying 8.98, so a slight reduction in accuracy as we've got a bit higher. Let's go up to 12, that's about 12.03, and that's 11.98. okay, it's still very close, and we'll continue up to what the maximum this will do. It's giving me about 15.2, that's saying 15.17. That's all right, quite pleased with that. Again, I'm sure if I can find out what those trimmer pots do, I can probably calibrate this, but that's for the future. Right, next thing to do is to check the current and probably the AC volts as well. So I'll get set up for that and then I'll be back. Okay, quick rearrangement of the probes, etc. I've got a 150 ohm resistor here, and I've now got the bench power supply. Both meters are all in series with this resistor, so we're going to compare current. So I've got the meter set for DC current. I've moved the connector over to the milliamps, same on the east tester, and this is the 2 milliamp range, and actually this has also got a 2 milliamp range, so I'm going to just gradually increase the voltage, which will obviously increase the current flow through the resistor. So I'm just going to come up till it reads 1 milliamp as best I can on the east tester. I can only look at one display. That's about 1 milliamp, and that's the same 0.998. okay, I'm not going to argue with that. And this is the 2 milliamp range, so I'm going to go right up to about 1.9 milliamps if I can get that accurately. It's quite a coarse control, but we are slowly getting there. So that's 1. It's about 1. But let's call it 1.9. That's saying 1.883. So it's within 0.01. So certainly okay on that range. Let's go on to 20 milliamps, and let's now, I'm just going to turn the voltage off for a moment. Let's change this to 20 milliamps. Well, so now we're on to the 20, well, it's the 10 and the 20 milliamps range actually, but to get 10 amps you go to that second socket. Right, okay, let's put some power on and see what we get. So let's try and get 10 milliamps, see what we're getting here, sort of middle of range. If I can do that, there's about, well, let's just let it settle. 10.4, 10.36, okay, it's all right on the second milliamps range as well. And let's go up to, if we can see if we can get to 19, easy, and right at the limit of the range. So that's 19.07, 18.96 again. It's within 0.0 and 2 or 3 points. That's not bad at all for a 1970s instrument, which I appear to have brought back from the dead. So that's the 20 milliamp range, and then we've got a 2 amp range here. So I'm going to just change that to 2 amps as well, and I need to just change connectors on there, otherwise I'm going to blow a fuse in my east tester. Easy to do, I've already done it once. So let's just put some voltage on here, and I'm going to go up to half an amp. Well, I'm going to go up to 0.05 amps, sorry. Yeah, so 0.054. 0.054. Wow, okay, that's pretty good on that range as well. That resistor shouldn't be getting too hot, which it wasn't. I'm going to up the voltage now, see if we can get to, that's 105 milliamps, and that's agreeing 104.6. yeah. Right, don't want to set fire to that resistor. It is getting quite hot, so I'll drop the voltage back down again. So not check the 10 amp. Next thing I need to do is, and I'm not going to do that today, but next thing to do is I just want to check the AC voltage and see what we get. So I'll get set up for that. Okay, so finally I'm going to just check the AC voltage range. So what I don't want to do while I've got these temporary leads is do anything of a particularly high voltage, obviously, until I've got some properly insulated leads. So I've got my signal generator switched on, producing 50 Hertz sine wave. I've currently got it set to 5 volts there, so I'm going to enable the output and let the meter settle down. So the east test is telling me about 3.5, and so is the Simpson, 3.53, 3.55. So bear in mind the signal generator tells me that it's peak voltage, and both these instruments here are measuring the RMS voltage, so that's what you'd expect. And yeah, the meter here is telling me 50 Hertz as well. So let's just go up to 10 volts. I think it's going to manage that. That's 10 volts peak to peak, 7.06, 7.01. okay, yeah, it's not bad. It's not going to let me go any higher, I don't think. No, that's about as much as I'm going to get. But clearly does measure the AC voltage. Okay, one thing, I'm going to now go back down to 5 volts, and one thing that it does appear to say, I did read it somewhere, that it would also measure AC voltage. No, I can't remember where I read that. Anyway, let's just increase the frequency. So that's 100 Hertz, and still giving me a reasonable reading. Let's go up to 1 kilohertz. So that's 5 volt peak to peak at 1 kilohertz, 3.54, 3.51. Yeah, and you can see the frequency readout there. Let's just go up to 5 kilohertz there. Yeah, still quite happy to give me a sensible RMS reading. I wonder if I can get to 10. Right, that's 10 kilohertz. Oh wow, okay, yeah, still pretty good. I'm going to push my luck now. 20 kilohertz. Yep. 30. Starting to creep up a little bit now, so starting to lose accuracy, but that's 40 kilohertz, so that's pretty good. And if I go absolutely stupid and go up to 100 kilohertz there, yeah, okay, it's a little bit off now, but certainly if I hop back down to about 40 kilohertz, still 30 kilohertz there. Yeah, I'm getting quite a sensible reading, so very pleased. Okay, well that's the Simpson 465 meter, seemingly brought back from the dead. I took a chance with me £13.48 on eBay, and it's worked out for the best. So well done, Simpson, for fitting a fuse that did its job. Somebody clearly thought about that carefully in the design, and it helped. So I'm pleased the transformer survived. I'm even more pleased that the transformer they fitted also has taps which are suitable for 240 volts. So that's the instrument now working on UK mains voltage, which is great. I was after a second bench meter, so that'll fit the bill nicely. It's probably good enough as it is for what I tend to use it for. If I can get hold of a manual, and if you are watching this and you do know of anyone who or anywhere I can get a manual or a circuit diagram, I'd be very pleased to find that out. If you could put it in the comments, that'd be great. And then I might have an idea what some of those trimmers do inside. They're not labelled with anything obvious, and I don't want to mess with things until I'm sure what they are. It's actually reasonable as it is, so I'm happy with that. Thanks very much for watching. Please remember, if you're going to do this kind of thing and you're working with mains voltage, be careful. You do it at your own risk. If you're not sure, don't do it. That's the easiest way. Hope you've enjoyed the video. It's free to subscribe. Please do. That would really help me. Thanks very much for watching, and we'll see you on the next video.